I'm really pleased that I was asked to come back. This is one of my favourite conferences because the tone of it, I think, and all the fun that we have is worth it. That's getting a bit creepy already. That is, to be honest. Okay. The photographer is meant to be here, right? Yeah. Yeah, you're fine. You can stay. Who's going to leave? So who the F am I then? Well, my name's Matt Ryer. F is short for fuck, by the way. I just didn't want to swear on stage, so. I can't see this, it's too little. I've done a few open source projects, including Testify, which got a shout out, but I was too modest to mention it and disrupt things sat down there. So, I did a couple of other testing frameworks. I am big on testing. I've seen the value of that too, and I've talked about it and things too. And I also have a book. I'm not one of those people that goes on about it. Some people do things like this, and there's no need. It's cheap. Do you know what I mean? No need for it. Or worse, if you don't own this, you're probably a person of very low intelligence. It's rude, if anything. So don't do things like this, guys. Okay, that's why that's there. Look, don't do this. So I want to quickly say thanks to everyone as well that's been involved in this conference, the awesome MCs, Gray and the team and everyone and stuff. We have it's such a fun conference, I think. So I just wanted to say thank you. Yes, thanks for starting that round of applause, Steve. It's ridiculous. Yes, and by the way, we've seen the new Go logo and stuff, so thank you, Cassandra, for hooking me up with an advanced copy. I love it. It's brilliant. So, why am I going to talk about things I don't use in Go? It's kind of crazy, right? I mean, some people, the nice talks that we have usually are people sharing experiences of things that have worked well for them. So why am I going to talk about things I don't use? Well, one of the things I think attracts a lot of people to Go and why it's doing so well is simplicity. And of course, if we could just not use some of the things in the language and in the tools, that's in theory even simpler. So in a way, it's an eye towards simplicity. You might also like why I don't use things, and you might also choose to join me and not use them, and then we could not go to a meetup about it, and do you know what I mean? Not just, and won't make a Slack channel about it and all that. There are some things I think we could even remove in the next major version of Go, which you're not allowed to talk about at conferences. But actually, most importantly, this is about new people coming on. As Go grows and becomes what it's becoming, we're gonna interact and meet a lot of new people that haven't done these kinds of things before. That's all that. So we want to make sure that we remove any of these barriers and stuff. And if there's big chunks of the learning process that we could jump over, we won't skip it completely, but we could lightly cover it and get focus on the things that make us more productive first. And so I always think of code as telling a story, right? The compiler can work with any old mess as long as it works. The compiler doesn't really care. But we do, right? The code is for us, it's for humans. And we have to be able to tell the stories that we want to tell to each other through code. So this is my quote that I'd like to put out there. I think the next version of Go should actually be smaller than the current one. I think it's an opportunity to trim things out and make things even smaller, which is a very Go way of thinking about it compared to other languages where every major release comes with loads of new features. I like the fact that we don't have that many features. So when I say I never use these things I'm going to talk about, I sometimes use them. But more or less, nothing's 100%, is it? Do you know what I mean? So don't hold me to it. I do sometimes use some of the things I'm going to talk about, but we'll get through it together, I think. Figure it out. So what makes the sweetest of code? Oh, there's a telly here too. It's rubbish. Don't need it. Don't need it. Just stand here. OK. So good code is simple. It's obvious, right? It's boring. We've kind of heard this again. It's very important, and it's a very Go thing to think. We also want to have kind of a good glanceability of code. We want to be able to just skim code, just look at it, and have a general idea of what's going on. And I think that's a good goal to have, because that's really how we work in practice. When you're looking for something, you want to just be able to quickly glance through it. Then you're like, this is the area. Let's have a look. And then you can sort of dig in and understand it a bit more. Code should be all self-similar and familiar and same as each other, as well as being the same within one team. And ideally, we should have one way to do something. I'm telling you this stuff because I think it's very important, but also it's what drives me to not use some of the things. So I got this quote from a beginner, and I was kind of devastated a little bit. Essentially, they started to learn Go, but there was just some early concepts that they came up against that didn't really resonate with them, and they didn't really understand it, and they wanted to quit. When I investigated this with them, it turns out arrays and slices was the issue, right? And I said, don't worry about it. Forget about an array, just use slices. Because you can be useful. You don't have to know about what's really going on under the hood in order to use it. You have to know what's going on to optimize it, but we can do that later. So we can start to be useful much sooner. So obviously, I'm not anti-intellectual. The more you know, the better. But we don't have to know it all right now. We can kind of defer some of that learning. Defer, by the way, is my favorite one, and I'm definitely not going to include that in this presentation because it's brilliant. But we should lazy learn things. So you know how we do lazy loading? Well, we should do lazy learning, right? I now need to solve this thing I've never done before. Well, that's a perfect time to read about it and learn about it because you've got the context about what problem you're trying to solve, and it's all real, and real wins. So these are the Go keywords. Just shout out, who can guess the three of these that I'm going to now claim I never use? Go to. Else. Else. Okay. Fall through. Yeah, okay, and here's the three. You were right, else. But I was just gutted that someone got it. I wanted that to be a surprise, and you basically ruined it. Yeah, go to, fall through, and else. No. Okay, and these are the built-in functions too. And there's actually, when I was doing the research for this, I didn't remember most of these. There they are. Yeah, apparently. Yeah, I don't know. These are the ones I don't use. Well, anyway, we'll find out. And it might surprise you to see that new is in there. I really don't ever use new. I think we should get rid of new. But let's talk about some of the reasons why we don't use these, or why I don't. Well, go-to is like the kind of classic. Basic used to be basically this. And they're not line numbers. They're numbers that you have to put in. And the reason they go up in tens is in case you want to put instructions between them. Because you're saying go to a particular line ID, which if you then were to change the line numbers and the order of things, it would break everything. So it's kind of crazy. Then we got labels. And Go actually has labels. This runs. But it's funny, it doesn't look like Go code, I don't think, does it? It looks weird. Like you're like, what's this? It sort of breaks the flow and stuff. And there's a reason for that. It's basically because with GoTo, it gets very, very quickly, it gets difficult to see. You know, spaghetti code is only possible because of GoTo. Without GoTo, it's just a long piece of pasta in that analogy. Should have thought that one through. Should you write that down? Just say, don't do any pasta jokes. So you can also we also have labels for breaking and things in loops. So if you have nested for loops like this, you can actually break the outer loop doing this, right? Most people don't know this. I don't know why I've told you about it, to be honest, because I think it's confusing and not very pleasant. And if you can change the structure of your program to avoid things like this, I think it's worth it. It's all right like this on one slide, when it fits on one great big massive telly. But when that spans, lots of lines and you've got all kinds of different bits and pieces going on, it's really difficult to follow, and you lose that glanceability. So when they're small and local, that's probably when I might use something like that. But things never stay small and local. So I don't use go-to, and I don't use labels. Subliminal. Else. Else is, thank you to my new friend who ruined it. Else, yes, I don't use else. Now, this is one where occasionally there's a time I'll definitely use else, but actually you really don't have to. And the motivation is this glanceability and having a good line of sight in the code. So line of sight is essentially the idea is that down the left edge of your function, that should be your happy path. And then anything that's edge case or something that just as an aside you have to deal with, then you can indent that. And if you do that, your functions are very neat. You don't end up going all the way to the right with tabs, so then you don't have this complicated scrolling and things you have to do, and keeps code kind of neat and tidy. And so that's the motivation. But if you're wondering how do you avoid else? You need it, it means otherwise. If this, otherwise this, or whatever. Well, this is how. So this is very common and completely normal, the way we think about writing code. We're going to do something and say, OK, if that's OK, then I'm going to do this. That's how we think about it when we're building things. But we end up, see the happy path is now indented. Now, if that happens a few times, then we have code that can be really quite difficult to read. And the trick is to flip the logic in the if statement. So if instead we say, instead of if OK, if we say if not OK, then we can return and deal immediately with that situation. And then we're back into our happy path on the left, and we can carry on writing our nice code that's neater, I think. So new is another one I don't use. I know what you're thinking. How do you write programs without allocating any memory? Was anyone thinking that? Yeah, right. Well, yeah, I still make things, but I use this format. And actually, I think we should just have this one. It's enough. Actually, there's two here. The default values for types, having that as a capability is very nice. So if ever I'm working with those sorts of types, then I always will just declare them like this. But if I've got structures that I need to actually create instances of, whether they are going to be local kind of value types or whether they're going to be pointers, I use this format. And I like this style because if I want to set the fields at the time I create it, it's sort of the same code, with if I don't want to do that. So in both cases, it's the same. And this is kind of like why I like the extra comma in lists of things in Go. It's so that you can it minimizes how much you have to change when you want to add things or tweak things or remove things. So yeah, this is the kind of style I never use new. And I was disappointed with my friend's report because, earlier, because arrays was this confusing idea. And I get it, because slices are an abstraction on top of arrays. And it's possible to write code that's somewhat inefficient, where many allocations have to happen as you're going about kind of building up this slice, which you can optimize if you know the length in advance, things like that. So, but I don't think you need to worry about that initially. You can just use slices, and it'll work fine, and probably it'll always just be great. You'll never have to worry about coming back. If you want to optimize it later, then you can sort of take the time to learn about what's the length, what's the capacity, what do these things mean, so that you can then write more optimized code. So I always just do that, and I use the empty default value as well of it, because append will create, essentially it creates a new slice that returns, so that's how I do that. But this is really it. If you do know the length of the slice, then you might as well create it with that length. If you know the maximum that something's going to be but aren't quite sure within that, then you can do it. But it's worth avoiding cases like this because it gets very confusing. So imagine you've done some optimization and you just find that if we put the capacity at 155, that just gave us the best result in our benchmarks. Well, that's okay, but that's a really weird thing to see in code. So when someone comes along and they see, oh, 155, why would that, what's that mean? It's going to be a kind of cognitive blur. And now it might well be meaningful, in which case you could have a constant and give comments and all that stuff. But practically, you know, the performance benefits from doing this, I don't think are worth the trade-off in readability. What? Oh, this. No, this is. I didn't put this in here. I don't know where this has come from. Don't do that. Panic. Who panics in code? Yeah, because we're in New York City. We've all had to cross the street. We've all panicked today. So yeah, I never panic. I always just prefer errors. So I don't ever use panic, except if I want to improve something that's already going to panic with a better, just a better message, then I'll do it. So I'll give you an example of what I mean. So we've all probably seen this. If you haven't seen this, you're going to see it. Invalid memory address or nil pointer dereference. It's a classic. It's one of our favorite errors or panics. So imagine we've got some code like this, and oh, that's gone too fast. Yeah, okay. So this is the first one. So we're going to ask the speaker to speak something. If that speaker is nil, that code panics with this error. And if you see that, you have to sort of go and figure out what's gone on. It's not as clear. But a little check like that can actually improve that error message. So it's still going to panic, but it tells you actually what's up. So I think panicking to kind of give just a better panic, I think is okay. But otherwise, just errors, I think, are always the thing. Structs without field names. So when you instantiate a struct, that's not the right terminology, but we'll edit that in post. We'll get some, yeah. When you do this, you can omit the field names and just rely on the order. If you do that, though, you kind of lose a bit of information. So obviously, my name's Matt Ryer, so probably first name, last name. Well, what's 42? Shout out, any ideas? What could 42 be? Age? 42? I mean age. It's not age. Definitely not. 42. 42? Can't believe that. Absolutely gutted by that. All right, not really. So the point was, the field names make it extremely easy to see what's being done. It's more verbose. You're writing things, you type more things, but it's clearer. And I might say, there are some times where I'm tempted to omit this, where it's like, oh, I've got a position, so it's lat long. Everyone knows that. Well, some APIs flip it, and you have longitude first and then latitude, instead of latitude and longitude. And so actually, it doesn't really help to just see, unless you happen to be familiar with kind of certain coordinate things, genuinely, like you might know that -74 is over this way, and whatever, I don't know, but I don't know where that is. I'm not pretending to be like you just give me a lat long and I'm like, Wisconsin. You know what I mean? It'd be a good superpower, though. Not a superpower, is it? Just remembering. That's not a superpower. Just remembering things. So believe it or not, I don't really use HTTP handler. I end up always using handler func. I think it's actually more useful. And you can do things like this, where I do it like this. I have a method, usually on a server, so that I can have shared dependencies. And I call that method and get back a handler, which allows me to do kind of setup for that particular handler. And then all I have to do is return a function. I'm kind of just dealing in functions. HTTP handler, for those that don't know, is just a simple single method interface that has serve HTTP method. So in order to build something that responds to HTTP web requests, all you have to do is create something that implements that method. Well, with handler func, you don't even need to create anything that implements that. You can just use the functions themselves. So I find that to be really quite satisfying. And yeah, you can do things like, you can actually take arguments into this little function, and you can do some work at the top before you return the function. So you can prepare your dependencies. If you're going to render templates, that's a perfect time to do it. Although if you have lots of these, it will affect the startup of your application, because the startup time, because they're all going to get called basically immediately. It's going to be doing all that preparing in advance. So there is a slight optimization you can make, which is something like this. You can be lazy about it. This essentially declares some variables outside, so these are going to be shared. And then we use sync once, which is, if you haven't seen it, it's awesome. If you're writing any code that's concurrent code, and by the way, if you're writing handlers, then you're writing concurrent code. They run, each request is handled in its own Go routine. And if you use sync once, you can basically guarantee that the code inside that block will only execute once, no matter how many times call this method at the same time, or try and access this endpoint. So that's quite a nice way to do it, too, if you like. And middleware is a lot easier with just HTTP handler func, too. Because you're just passing functions in and out, and you can just return functions. If you return this function here, it's automatically cast to an HTTP handler func. So you get that kind of for free. If you're using handler everywhere, there's just more you have to do. But you can still do it. It's just a little bit more. I actually don't. Could everyone not look at this? Because this really is weird. Most people don't even know about this. I'm sorry to tell you, but definitely never do it. But it's too late now. So we have a struct here called greeter, and it has a method on it called greet. Well, you can call the greet method directly, like I do at the bottom. You can also call that same method by using the dot notation on the struct, and pass it in the receiver, the struct you want to work on, as the first argument. Because technically, this second one is just sugar, syntactic sugar around what's actually going on. I think we should disallow that from working. Steve, if you could sort that out on Monday, mate, that'd be brilliant. Yeah, it's going to do it. Yeah. And so, yeah, the whole kind of point about this thing really is the fact that Go, we've seen it did really well as a systems language. It's really kind of earned its name there. But it's being used, as we've seen today, in all kinds of new and exciting and interesting and weird and awesome ways. So I want to welcome everyone that's new and anyone that's thinking about learning Go. Definitely do it. You're very welcome in this community. If you've ever not felt welcome in a different tech community, then come and try Go, because from the beginning we're trying to do this differently. We're trying to get it. So yeah, get stuck in and don't obsess over the performance. It's very tempting when you're learning to want to know everything, like what's the best settings for this slice so that I don't incur any unnecessary applications and stuff. And definitely learn it if you're interested in it, but it won't change what you write that day. It won't change any of the behavior of it, and it won't really improve the code very much. It might, at scale, give you a performance hit, and that's great later. We'll sort that out later. Let's just get a slice working first. So, come and join Go. We want you to please do this. And then, bye. That's it. Thank you very much.